Okay, so now we want to find out how can river hazards be mitigated. So in order to do that, we're going to need to know how often does a river flood and how severe is that flooding. And so these two charts are illustrative of the Yellowstone River in Wyoming in North America. And the first step is to measure the maximum flow rate of your river over a period of many, many years. So let's make up a graph here. So this is going to be the graph that's on the left. Over here is going to be what was the maximum discharge for the Yellowstone River for various years. So for the entire year of, let's say, 1876, what was the maximum discharge of the Yellowstone River at flood stage? And let's just make up a number, and let's say that it turned out to be 100 gallons per second. Or you can think of it as 100 cubic meters per second. So we're just making up numbers. So let's say that that was the maximum flow rate of the Yellowstone River when it was flooding in 1876. Okay, then we go out in 1877 and we again measure what was the maximum flow rate for that river in 1877, and let's say that it wasn't this high. So maybe it was down here and it was at 75 gallons per second. And then in the next year, so 1878, let's say that it was right here. And then over a period of time, what we're going to get is a series of dots that are going to illustrate when it had its maximum flow rate for each of those years. So that's what the one on the left shows. Now notice that they did it for a lot of years. So like for 100 years, they measured the flow rate of the Yellowstone River. Well, that's a lot of data points. So we're going to keep it simple here. So let's just say that we've got 1, 2, 3, 4, 5, 6, and let's just throw some more in here. So we got a 7 here, and then an 8, and then a 9, and then how about let's put one over here. So let's just say hypothetically that those are our 10 data points. Okay, now we're going to make up a second graph. So here is going to be our second graph. This side over here is going to be exactly what this one is. So this is again going to be the maximum discharge of the Yellowstone River. Okay, now let's start off with our highest one, which was, let's just say it's this one here. So let's say that this one turns out to be taller than this one. So I'll put that one down a little bit lower. All right, so this is our maximum discharge for all of these other discharges. So it would plot up here. And now what percent of all of these floods had a maximum discharge of 100? Only one out of 10. So that would mean that if we go over here, we could put down 10%. So 10% of the floods would have a maximum discharge of 100 gallons per second. Okay, now let's go down a little bit lower and let's look at this one here. So let's say that that one's a 90. So how many of them had a flow rate? So this was 100. So how many of them had a flow rate of 90? 2 of them. So 2 out of 10 would be 20%. So over here, we're going to write down 20% of the floods had a maximum flow rate of 90. Okay, and then we could go down a little bit further and we could pick off this one right here. And we would then say that 30% of them might have a flow rate of maybe 85, and so maybe it's down like this. So if we continue to plot all of this, we end up with a curve that looks something like that. Now, the more data points we have, the more accurate this is going to be. And so now we have something that we can work with. So we could say, what's the likelihood that a flood produced by the Yellowstone River is going to have a such and such maximum discharge? So let's say that we're interested in 50. So we would find 50 on here, and we would bounce it off the curve, and then that's going to tell us what is the percent chance that that particular kind of flood is going to occur. Okay, then we could make up a hazards map, and we could draw a map of the Yellowstone River, and then if it did have a discharge of 50, then that would mean it's going to overflow its banks and it's going to have flood on a certain distance away from the river on both sides. And we could color that in on a map. So let's just say over here, I'm getting kind of messed up here, so let's erase some of this. And let's draw a map now of the Yellowstone River. If you got something else better to do, then just go ahead and do that while I'm erasing here. Okay, so now I'm ready. So now we're going to draw a hazards map. So here is our map. Here is the Yellowstone River. Okay, and now let's say that we're interested in knowing what's going to happen when it has a maximum discharge rate of 50 gallons per second. It's going to overflow its banks, and so we can calculate how far is that water going to travel once it gets out of the river. And so then we can assign a probability to this, and so it looks like it's going to be less than 30% or greater than 30%, so maybe 40%. So that this stuff in here is going to represent a 40% chance that that river is going to flood out that far. Okay, now if we want to know what's the 20% chance, so the 20% chance, we're going to bounce it off the curve. Looks like it's around 90%. And so we could calculate how far would that water travel, and so maybe it would turn out to be out here somewhere. So then we would say that all of this in here would represent the 30% chance of a flood. So by doing this, we can construct a map that's going to give us probabilities of different kinds of floods. Now, how's that going to help us? So once we know what's the probability that a flood is going to occur, we can then come up with building codes. And we could say that if there is a 90% chance that the water is going to be in this region here, don't build your house there. So it would be illegal to build your house in that area. Or if you want to build your house in that area, you're going to have to pay really, really high insurance rates in order to be able to do that. Okay, so let's take a break, and we'll be right back.